So here basically we're just looking at what's in each of these codes. As we've said, they're very similar. So basically these outlines look very similar. We've got some general descriptions. We've got the building envelope requirements, HVAC/mechanical systems, water heating, lighting, other equipment, and then this thing down at the bottom here with Ashrae 90.1 called Energy Cost Budget Method, and over in the IACC Total Building Performance. This is basically looking at an alternative compliance pathway to show that basically you won't spend any more money on energy than a building that's exactly like yours and meets code. And this basically gives us sort of the architects gone wild flexibility down here to do whatever we want.
Okay. And again, the scope is very, very similar, just, slightly different arrangement and sort of numerology.
Covers the same topics, almost the same layout in terms of the order that these items appear within each book. We've got what we kind of refer to as multiple compliance pathways. We've got mandatory requirements within both of these codes, things you have to do no matter which pathway you choose, things that can't be traded off, things that can't be excluded.
Such as air sealing. You got to do air sealing. There's no trade-off for that.
Certain types of controls, things like that. We've got the prescriptive charts, which is over here in green. Both codes have prescriptive charts, and this is basically the answer. If you want to follow the prescriptive pathway, these charts tell you what needs to be in the building in terms of insulation based on assembly type. This is sort of the...
Okay, I'm sorry, before you go to the next one, keep going.
I was still on this one.
I'm sorry.
This is sort of the simple answer for tell me what I need to do with this building. The chart will tell you, and as long as your building does it, you comply. If you use the prescriptive pathway, though, you have to be in 100% compliance. Prescriptively, everything has to comply.
And what I was going to say is the prescriptive chart for Ashrae, the values in it are very, very similar to the prescriptive chart for IACC 2009. So that's good, Chapter 5. So Chapter 5 and Ashrae are very, very similar, but Georgia did make some adjustments to the prescriptive chapter for Chapter 5. We did not mess with 90.1. So we'll emphasize that when we get into it. But if, like Burke said, if you don't want to have to do any trade-offs, just build exactly to the rules, and you pass code, you collect $200.
Don't go to jail.
Don't go to jail. All right.
Here in the middle, we've got Comcheck. We've alluded to this a couple times already. It's sort of a simple trade-off tool. It's a free piece of software. You can download it online. It allows you to show compliance with the energy code, and it also gives you the ability to do a little bit of trading off. So we can trade one envelope feature with another envelope feature. Gives us a little bit of flexibility as we're moving away from the purely prescriptive approach.
Everybody catch that? So it does not do super sophisticated energy modeling, which is nice. It's pretty simple to use, and we'll demonstrate that. And if you saw ResCheck or have seen ResCheck, it's very similar to that. But the version of Comcheck that's out there now, actually you can reference this version or you can reference 90.1. The problem with this version is Georgia changed some things. So really, if you're going to use Comcheck, you kind of need to use 90.1 as the base code. But like I said, it's actually going to potentially work to your favor. It's a little simpler in a couple things. But again, very similar. Okay?
And then finally, this building simulation, as we said, there's sort of some rules for doing this within each of the codes. And this basically looks at building a base case building that just meets code and then comparing your design to that building based on energy cost. How much money would we be spending on energy in this building? Compare the code building to your building, and if your building spends less dollars on energy, then basically it is considered to comply. And there's some rules for doing this. We're not going to look at it too much, but we want people to be aware that it's out there. It's a tool. It's something that's used within the LEAD program. And it's really what allows us to get really far away from the prescriptive requirements and do some things that prescriptively wouldn't pass code, but based on simulation, we're able to trade those things against maybe better performing parts of the building and show that we're compliant through the dollars that we're actually spending on energy.
Okay, everybody good with that? I think that's a good visual sort of indicator just to think about what, how the day is going to go. We're going to spend a lot of time on this, and we'll demo this, and brush on that a little bit. Questions? Anybody have questions? All right. Applying the code, what commercial buildings, are we talking about? And, basically this definition of conditioned space kicks in. Without going too deep on it, if it's unconditioned space, it has nothing in it or next to nothing in it. If it is conditioned, it has fairly low amount of energy being supplied to cool it or heat it. That's not a lot of BTUs per hour. And also indirectly is defined as essentially basically spaces such as if you foam the roof line, like Joe was talking about earlier, it's been clearly spelled out. If you foam the roof line, that is considered indirectly conditioned space up there. So that is inside the envelope. And Ashrae has this, the other code does not, this thing called a semi-heated space. It's a space that has a little bit of heat, but not very much. It has more than 0, but in this climate zone, less than 10. And an example would be a warehouse that just has a small amount of heat, and it's only so pipes won't freeze. That's really it's very, very minimal, though. Yeah, Tracy.
Mike, just as a kind of clarification point, but between floors, let's say it's an open web floor truss.
Right.
What would you consider that space?
Well, it would be inside the envelope in the sense of the band area needs to be insulated and air sealed. So. Yeah, so in that case, I would consider it indirectly conditioned space.
It doesn't really matter the depth of that space, whether it's 20
No.
feet or 2 feet.
Yeah, I mean, and a lot of times it gets used as a plenum, right? That space can get used as a plenum, or it might be used as a return plenum or something like that. So it's inside the envelope.
I guess more specifically then, if you had ductwork passing through that space, do you insulate it?
It's
Non-conditioned?
Yeah, we can, and there's, the simple answer from the simple answer is generally that ducts that are fully inside the conditioned space are not required to be insulated. You should always insulate supply ducts a little bit. For what reason? To prevent condensation. But what I was going to say is when we get into the mechanical section, there's actually a chart that shows this location of ducts, and it's kind of all over. I mean, they have a lot of different things, but generally the most R value they want on ducts is, the most they ever want is like 6, I think. Is that right, Burke?
Yeah.
And I can look it up on the chart. So when we get to that section, we'll answer that. But in general, if it's inside the envelope, it really does not technically have to be insulated from an energy standpoint. Because if it lost energy, it would be to the inside of the envelope. You should always insulate it for condensation reasons. Good. That's a good question.
The only other thing here, when we look at the Ashrae prescriptive charts, you'll basically see non-residential, residential, commercial, and semi-heated. So the chart will actually have 3 separate columns based on the type of construction that you're dealing with. Non-residential is most commercial buildings. This says residential. I kind of think of it as residential commercial. It's commercial buildings where people are going to be sleeping primarily. You've got sleeping quarters, people spending the night. Ashrae sort of gives it its own special column, sort of reflecting some of the different, uses of energy within that building. We say they're typically more skin load dominated, where commercial buildings are typically more internal load dominated, and the chart basically reflects that. And then for that semi-heated building, we've got some separate requirements. Very few buildings are going to be semi-heated. Because it's really a very small amount of energy that you can put into that space and fall into that category.
Yeah, I mean, just as an example, if you had let's say a 10,000 square foot warehouse, you would be in this climate zone, if you put in up to 10 BTU per hour per square foot, so that would literally be 100,000 BTU space heater for a 10,000 square foot warehouse. That's not very much. And if you put more than that, if you put 50,000, excuse me, I said 100,000. All right, let me back up and say I've screwed myself up here. So how big is my warehouse?
10,000.
Okay, so my warehouse is 10K, and the limit on this is, 10 times that number. So I could have 100,000 BTU space heater or some sort of heater, 100,000 BTU per hour heater. That is not a big, that's what you would see in a house maybe. That's not a huge thing. But if you put more than that number, let's say you put 300,000 instead, then in that case, you're kicked out of the semi-heated possibility, and now you're up into conditioned. Okay, so now, and what this is saying is, when you look at the tables for these three categories, the condition, is going to, the fully conditioned spaces are going to have more R value requirements. A semi-heated building is going to have less. It might not have any wall insulation in it. So you have some differences there. Okay, everybody catch that? So really, this only applies to warehouses. Okay, once again, 95% of all commercial buildings that have people sleeping in them legally, and then
legally,
and then buildings that a warehouse with freeze protection. Just for the record, too, Ashrae has these three categories. The Chapter 5 does not have that bottom one. Chapter 5 just says there's two kinds of commercial buildings, these and these. And Alan, you were talking about this. The previous version of the code for Chapter 5, it only had one, all buildings, one answer. So I kind of would argue that all commercial buildings do not behave the same. And so I think you could argue maybe that we really need we need that. Instead of being 3 kinds of buildings, it should be 6 kinds of buildings. But this is the price you pay for simplicity. So in general, the simple answer is this is the column that we're mainly going to worry about, with a few other examples. Everybody okay with that? Yes?
Why is there no consideration for volume and just square footage?
Probably because volume is probably not the most direct way to talk about heat gain and loss in a building. It's really more about surfaces. If you think about it, heat conducts through the insulated, or doesn't conduct or slows down through. It's the shell of the building that really matters, less so than the volume. I think that's probably why. But
is your square footage calculation per floor or per building?
For what?
Well, like a conditioned space.
like if you,
Oh, it's per floor. It's per floor.
yeah.
Yeah.
I mean, if you had a 3-story building with a 10,000 square foot footprint, that's
yeah.
a 30,000 square foot
But if you had a
building
30-foot tall warehouse,
Then it would still be 10.
because it's
10,000.
one floor. Yeah.
Yeah.
So it's not perfect.
It's, in general, I don't think that lasts. We probably beat that to death, but semi-heated just doesn't occur very much. So is everybody okay so far with this? Let's talk about what does apply to the code.
So you'll notice we've got 3 bullets here, and each one of them starts with new. So I think that's really the key thing here. New work has to comply with the code. So whether it's a new building, a new system within a building, a new addition, a new portion of a building, a new portion of a system, or a replacement of existing equipment, anything new has to comply with the code.
I think that's a good question.
I got a specific question about that. If you're carrying off an existing roofing system, including that insulation, have you got to clean that insulation now?
Well, let's answer your question. What a great segue. Thank you so much. I appreciate that, Randy.
So we've got some exceptions to this requirement, and they're basically spelled out here. Do you want to go straight to the roofing one? And then
No, let's
hit
just
on
do
the
them in
others?
order. Is that okay? We'll work our way down here. So this is what the definition of an alteration is listed in Ashrae, and we put it up there. And then they say, in general, like Burke said, the general statement is new work needs to meet code, but there are a couple of exceptions where, the code does not have to kick in.
Yeah. So what we're looking at here, the first one basically says you can put in a storm window, and the window that it's going over doesn't have to comply with the code. That makes a lot of sense. Seems really fairly reasonable. It says you can replace the glazing within a window. So you've got a broken pane, you can replace the glazing as long as the glazing that goes back in is no worse than the glazing that was previously there. And we've got C here, alterations to a roof, ceiling, wall, or floor cavity in which there is already insulation. So it basically says if I open up this cavity and there's already full depth insulation within that cavity, I don't have to tear that out and put in new insulation. So if you open it up and there's already insulation in there, you're allowed to leave that insulation in place. Doesn't mean you couldn't choose to improve that insulation if you wanted to, but you're not required to by the code. Also here it says if you don't have any framing cavities and you're not creating any framing cavities, you don't have to add any more insulation. That kind of makes sense. And then we come to roof membrane. So we're basically saying we're replacing the membrane, but we are not removing the sheathing or the decking. In that case, we don't have to...
not exposing it. Is that
not
what you did?
exposing the sheathing or the decking. In that case, we don't have to do anything. We're allowed to just replace the roof membrane. So do those two kind of cover The question,
And well, and the last one, the last line on there too says, or if there is existing insulation below the roof deck, so you're not required to. But
which is kind of covered by.
yeah, kind of covered by the previous one. Yeah, well, what it's really saying is it's saying, look, we're trying to be reasonable here. If you're essentially just resurfacing the roof, you don't have to do anything. You know, if you're going to put, if you're pulling off the shingles and putting new shingles on, you're okay. That's probably not the best example. If you're taking the roof membrane off, though, and you get down to the decking and there is no insulation in that roof, this is a good time in the life of this building to bring it up to code.
Yeah, except for all that equipment that's sitting on the roof has to be now moved off the roof, raised, new curbs.
You're correct. There are implications. I'm not trying to assume otherwise, but in its life, this is a good time. This is the point at which we need to bring that component of the envelope sort of up to snuff.
You can't go back to what the insulation was. You got to bring it up to whatever.
That's what it's saying. Now, you know, it does have that thing about if there is, well, that's if there's a cavity and you insulate and you do some renovation, let's say from underneath, and you see, you know, an R19 bat or whatever or something, as long as it's a nominal R3 per inch, which that would probably make it, you're not required to kind of rip it all out and start all over again. But if there's no insulation, then you have to do it. So if like Burke said, but if there's a cavity and you don't tear into it at all, then that's okay. But if you pull up a piece of decking and there's you have access to the roof now, they're basically saying, in this case, you got to insulate it. I'm going to say, read these carefully and see if you can figure them out, and which one applies to you. There are some exceptions, and these are all exceptions. But in general, if you pull off the roof membrane and there you expose the decking, this is the time now to bring it up to code. Is that
fair enough?
Fair statement? You know?
F basically says you can replace existing doors that are between interior and exterior without having to add on a vestibule. However, if there was already a vestibule there, you can't take that vestibule down. So basically they say you can put new doors on without adding a vestibule unless there's already a vestibule there, in which case we want you to retain the vestibule. And then G basically says you can replace up to 25% of the glazing, providing that what goes back on is no worse than what was there. But if you go over that, everything's going to have to comply with code.
And that last one, let me say that there's a very similar list that applies to Chapter 5. It's not identical, but that last one is unique to Ashrae. So Ashrae says, I guess, that you can replace some of your windows, and as long as it's less than a fourth of them, you don't have to. Those do not have to meet code, as long as they're no worse than what was there. A little bit just sort of how one code approaches something versus how another code approaches. But in general, I think it goes back to new work needs to meet code. Does anybody have questions about these envelope changes? Okay, good stuff. We want to shift gears and talk about envelope. I think this might be a good time to take a